Alright, today I want to go ahead and discuss Lesson 6.4, Trapezoids and Kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The bases of a trapezoid are the parallel sides. The legs of a trapezoid are the non-parallel sides. And the isosceles trapezoids, it's when the legs are congruent. Okay, so here we have a trapezoid. It is a quadrilateral, so 1, 2, 3, 4 sides with exactly one pair of parallel sides. The bases of a trapezoid, we can see that these lines are parallel, or these segments are parallel. So we consider those parallel sides the bases. The legs of a trapezoid are the non-parallel sides. And then isosceles trapezoid is when the legs are congruent. So let me draw a trapezoid. These are parallel, so I'm going to draw an arrow here. And then the non-parallel sides, which is this, and I'm going to draw tick marks to show congruency. This is what I call an isosceles trapezoid. Let's go ahead and take a look at their theorems. The theorems of isosceles trapezoids. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So if angle M is congruent to angle L, then we can say that this trapezoid here is isosceles. Trapezoid KLMP. Okay? And this is basically the same idea with an isosceles triangle theorem. When, two angles are congruent, then the sides opposite to those angles are congruent. If a trapezoid is isosceles, then each pair of base angles is congruent. So this is the reverse. So suppose that, let's see. If a trapezoid is isosceles, then each pair of base angles is congruent. So we know this is an isosceles trapezoid because of these two tick marks here. So the angles opposite to those tick marks, we can see that angle H is opposite to this tick mark, and angle G is opposite to that tick mark. Those base angles, okay, because we call these the base angles because these angles are, on top of the base, then we can say that those angles are congruent. These angles are also congruent, right? And they get two arcs here. This arc is opposite to this tick mark, and this arc is opposite to this tick mark. Okay, so if trapezoid GFJH is isosceles, then angle G is congruent to angle H, and angle F is congruent to angle J. Okay. A trapezoid is isosceles if and only if, so this is a biconditional, goes both ways, if and only if the diagonals are congruent. So if trapezoid QRST is isosceles, then we can say that segment QS is congruent to segment RT. Okay. So, once again, if this the trapezoid is isosceles, then the diagonals are congruent. And it goes the other way. If segment QS is congruent to segment RT, so if these diagonals are congruent, then we can consider this as an isosceles trapezoid. So then trapezoid QRST is isosceles. This is using the converse theorems. Okay? So, here we go. Example 1 for isosceles trapezoid ABCD. If the measure angle D is 2x plus 24, and the measure angle C is 5x minus 15, find x. Well, know that this is an isosceles trapezoid. So what does that mean? Well, first of all, let me go ahead and mark my picture. So again, this is an isosceles trapezoid. So that means that these lines are parallel, and these are my legs. Okay, the non-parallel sides. And since this is an isosceles trapezoid, those legs are congruent. Okay? That means that the angles opposite to those tick marks are congruent. So what do I do with these two expressions? Well, I'm going to set them equal to each other. So then I'm going to get 39 on the left-hand side, which is equal to 3x on the right-hand side. And if I divide, I get x equals 13. Example 2. For trapezoid ABCD, if AC is 2x plus 4 and BD is 5x minus 17, find the value of x so that ABCD is isosceles. Okay, so AC, I'm going from A to C. That means it's a diagonal. And BD is going from here to here. That's another diagonal. It says find the value of x so that ABCD is isosceles. So this is basically utilizing this. A trapezoid is isosceles if and only if the diagonals are congruent. Okay? So we can go ahead and say that the diagonals here are congruent. So BD is 5x minus 17, and AC is 2x plus 4. Since these diagonals are congruent, then we can say that 2x plus 4 is equal to 5x minus 17. So then, doing the algebra, I am going to get 21 equals 3x, so 7 is equal to x. That's my answer. Alrighty, so let's go ahead and take a look at example 3. Quadrilateral ABCD has vertices A, B, C, D, those points. Show that ABCD is a trapezoid and determine if it's an isosceles trapezoid. Okay, so I'm going to go ahead and take a look at this picture that we have here. I'm going to go ahead and label those points, -3, 4. And B is going to be 2, 5. C is 3, 3, and D is -1, 0. Okay, so what I want to go ahead and do is I need to prove that this figure is a trapezoid. And remember, with a trapezoid, it is a quadrilateral with one pair of parallel sides. So, meaning, okay, so these are my sides. So this side, this side, this side, and this side. If I can show that these sides here are parallel and these sides are not, then this is a trapezoid, okay? So I'm going to go ahead and find the slope of BC, okay? And remember, the slope formula is m equals y2 minus y1 over x2 minus x1, okay? I assume you already know how to calculate the slope, so I'm just going to go ahead and skip the steps here. So I'm going to find the slope of BC. So here's B and C, and finding the slope using those 2 points, BC is going to give me, the slope of BC is going to give me -2, okay? And then let's go ahead and find the slope of AD. The slope of AD, if I calculate it, if I plug it in to this formula here, I'm going to get -4 comma 2, or sorry, not -4 comma 2, -4 over 2, which is going to reduce to -2. Okay, so that means that, okay, so this is -2 and this is -2, right? So that means that these slopes here are indeed parallel because they have the same number, the same slopes. Great, but that is not enough to justify whether or not this is a trapezoid. I have to show that these lines here are not parallel. They don't have the same slope. So let's find the slope of AB. And if I find the slope of AB, that's going to give me 1 over 5. And if I want to find the slope of this one right here, which is DC, well, the slope of DC is going to be 3 over 4, okay? So, great. Again, let me recap. This here, with these two, these two slopes, they are parallel. And these two slopes here are not parallel. So the conclusion that I can make with these two things here, it is a trapezoid. But the question here is it an isosceles trapezoid? So yes, I proved that this is a trapezoid, but is it isosceles, meaning that those two sides are congruent? And to figure that out, I'm going to have to use the distance formula. Okay, so then distance formula of what? What am I plugging in for the distance formula? Well, you're going to have to use the distance formula twice on this one, but you're really going to find the distance between these two diagonals here. Okay, so if I look up, it's dealing with this property. A trapezoid is isosceles if and only if the diagonals are congruent. So if I could show that these diagonals are congruent on the trapezoid, then it's an isosceles trapezoid. So I'm going to calculate AC. So I'm going to go ahead and put it right here. So the distance of AC is, well, it's going to be -3 minus 3 quantity squared plus 4 minus 3 the quantity squared, and that's going to give me root 37. And that as a decimal, let me see, that's going to give me 6.1 approximately. And let's go ahead and find BD, which is 2 minus -1 quantity squared plus 5 minus 0 quantity squared, and that's going to give me the square root of 34. And is that going to give me, let's see, what's the square root of 34? That's 5.8 approximately. Okay, great. So I know that this figure is a trapezoid. I proved it by calculating the slopes of the sides. And I'm finding the distance between the two diagonals here. That's great. And I know that these two diagonals are not congruent because I already calculated them. So is this an isosceles trapezoid? Absolutely not. This is not. So with this, with the information here, it's not isosceles. Did I spell that right? Hopefully I did. It's not isosceles, but is indeed a trapezoid. Okay. So that's the notes for example 3. let's talk about the mid-segment of a trapezoid. The mid-segment of a trapezoid connects the midpoints of the legs of the trapezoid. So, these are my parallel lines. And the non-parallel lines are the legs. The mid-segment connects the midpoints of the legs of the trapezoid. Theorem 6.24, trapezoid mid-segment theorem. The mid-segment of a trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. Okay? Remember, the mid-segment connects the midpoints of the legs of the trapezoid. So in this case, this is the mid-segment, and it is 1/2 the sum of the lengths of the bases, which again are the parallel sides. So that means that this is 1/2 of this plus this. So if segment BE is the mid-segment of trapezoid ACDF, then segment AF is parallel to segment BE, and segment CD is parallel to segment BE. So BE is 1/2 the sum of AF plus CD. In the figure, LH is the mid-segment of trapezoid FGJK. What is the value of X? So I'm going to use my formula. The mid-segment is equal to 1/2 of the base 1 plus base 2. And I'm just going to go ahead and put that here as well. 1/2 or 1/2 B1 plus B2. Sorry, I'm going to say or mid-segment is equal to 1/2 times the quantity B1 plus B2. The mid-segment is 15 because this states that LH is the mid-segment. All I'm doing is replacing the mid-segment with LH. And that is equal to 1/2 of, here's my base, that's X, and here's my other base, that's X 18.2. So then what I'm going to do is I am going to multiply everything by 2. And the reason being is I don't want to deal with this fraction, and I can see that if I distribute everything is going to get a divide by 2. Okay? Because I can rewrite it like this if I wanted to. Okay? And then when we see that number there, when we see a number in the denominator, we're going to basically do the inverse operation. So I'm going to multiply everything by 2. And these 2's cancel out. So that's going to give me 30 equals X plus 18.2. And if I subtract both sides by 18.2, I get 11.8 equals X. Okay? And this is my answer. A kite is a quadrilateral with 2 pairs of consecutive congruent sides. If a quadrilateral is a kite, then its diagonals are perpendicular. So here's my kite, and it is a quadrilateral with 2 pairs of consecutive congruent sides. So, I should be looking at this kite. I didn't notice the kite was there. So that means that these sides are consecutive and they are congruent. These sides here are consecutive and congruent, okay? So if a quadrilateral is a kite, then its diagonals are perpendicular. I have these diagonals, and they intersect at a 90 degrees. If quadrilateral A, B, C, D is a kite, then we know that segment AC is perpendicular to segment BD. Okay? And remember, that means they intersect at 90. If a quadrilateral is a kite, then exactly 1 pair of opposite angles is congruent. For example, I have this image, okay? And what I like to think about this is this. We like to say that the head and the tail, they are not congruent, but the wings are. So if quadrilateral JKLM is a kite, then segment JK is congruent to segment KL. And so if quadrilateral JKLM is a kite, and we know that segment JK is congruent to segment KL, and segment JM is congruent to segment LM, then we can say that angle J is congruent to angle L, but angle K is not congruent to angle M. Okay? So I really want you to think the wings are congruent. So here's an example. If FGHJ is a kite, then find the measure angle GFJ. Okay? So, what do we know? Well, I can see that this is a kite, and these angles are not congruent because that's the head and the tail. But the wings are congruent on a kite, so I don't know what these 2 things are, and you know what? I'm just going to call them X for each, because those are my unknown. So, these are dealing with angles, the sum of the interior angles of a quadrilateral, because yes, it's a quadrilateral, right? These angles add up to 360 degrees. So I can just say X plus 128 plus 72 is 360 degrees. These will combine to 2x, and then these 2 things, that's going to give me 200, which is equal to 360. So if I minus both sides by 200, well, y'all, that's going to give me 2x equals 160, so x is equal to 80. So these are 80 each. Example number 5, if WXYZ is a kite, find ZY. Okay, well, know that I'm trying to figure out what ZY is. But know that of a kite, the diagonals are perpendicular. So then if I were to replicate this triangle, and my goal here is to find this missing side, zy, this is basically utilizing the Pythagorean theorem. A squared plus b squared equals c squared. And remember that anything across from the 90-degree angle is what we call my hypothesis C. So this is the hypothesis. So then, let's go ahead and start plugging things in. So this is 8 squared plus 24 squared, which is equal to c squared. I'm taking the square root on both sides. So then, this is going to give me approximately 25.3, which is my C. What did I just do? I didn't mean to call this the hypothesis. I meant to call this the hypotenuse. My bad. Alright, bye-bye.